TCP IP subnetting part 3. We're going to pick up right where we left off by looking at how we subnet a class A address using my 3 steps. So we have this class A network 20.0.0/8. So this company requires 200 networks. So step 1, we ask ourselves 2 to power what will give us 200. So this is where we need to have written our handy binary chart. 1, 2, 4, 8, 16, 32, 64, 128. But for 200 we need to go a little bit further. 128 times 2, that is 256. 256. So this is 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4, power 5, 6, 7, 8. So in that case, our x is 8, because 2 to power 7 would give us 128. So we have to go with 8. It will give us 256. These guys require 200 networks or subnets. Will have met and surpassed the requirement. So in this case, our x is equal to 8. So now we convert the subnet mask into binary and add the number of bits you determined in step 1. So for a /8 we have, so this in first of all in decimal, this is 255.0.0.0, and that's why we are so if you convert this to binary, you have 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So that's that in binary. So now we count the number of ones that we determined in step 1, and we start from here. So we have, they are 8, yeah. So it seems this whole thing will go. So we have 1 2 3 4 5 6 7 8. So all those zeros are borrowed, or they are masked. They are now part of the network bits. And we have created 256 networks, because we say 2 to power network bits, which is 8, and that will give us 256. For the hosts, every subnet will have 2 to power 16 hosts, which is some 65,000 something hosts. That's not practical. You cannot have a LAN that have 65,000 networked devices, but we are just going here. We just want to learn how to do that, to do subnetting. So now convert the new subnet mask back to decimal and find your increments. So the new subnet mask, of course, is 255.255.0.0. if you have to convert this whole thing back now into decimal. Now to find our increment, I said that you take the last bit and you note the the octet that it is in, and that's where your increments will happen. So in this case, if you were to list that whole because there are 8 bits, if you do 1 2 3 4 5 6 7 8, the last one is matching to 1, yeah. So this is why I'm saying that you have your 1 2 4 8 16, 32, if I can squeeze it there, 32, 64, 128. Yeah. So this is where I'm saying that you just match the last one. So if say we had 2 to power 9, if let's say that we determined that our x need to be 9, so of course the last one would have been here. So in that case it would have been 128 as your increment. Yeah, because if you're to line up your chart there, you'd find it to be 128, because here's where you'd have 1, 2, 4, 8, 16, 32, 64. So the last one in that case it would be 128, but in our case we have seen it is 1, it is matching to 1. That is now our increment. So I'm emphasizing on that because that's what gives some people challenges when you're subnetting a class A or B subnet. Many people will say that those subnets are challenging. So to get our increments, so first of all, the original network we had was 20.0.0.0/8, but now there'll be /16. So to list the subnets, 20.0.0.0/16. The next one will be 20.1, because our increment is happening at the second octet. Yeah, so this is what I was saying that, or I was insisting that you note that where the last network bit falls in. So we can see this is the first octet, and I'm bolding it so that we see, because now my slide is cluttered. So in the second octet is here where our last bit, so we note that our last bit is matching to 1, and where it is, that's where our increments are happening. So in this case is .1.0.0/16. So we have 20.2.0.0/16, 20.3.0.0/16, 20.4.0.0/16. So we can continue writing like that until down until we have some 65,000 subnets of this. So we have just listed 4 of them, and so from here to get the usable IP addresses and all that, if you were to draw that table of first usable, last usable, and the broadcast, so I said that it's always good to start with the broadcast, because the broadcast is always the last IP address before you get to the next network. So our broadcast here would be 20.0.255.255. You can see that's the last IP address before you get to 20.1 dot whatever. To test, you can if you take 20.0.255.255, you add 1, this will be 256. So you cannot have a 256 in an IP address, so that will be 0. You carry, that will be 256 again, it becomes 0, so you carry 1, so that's how you get 20.1.0.0. That's what we have there. So you can continue with that logic. .255.255. So for this other subnet is 20.2.255.255. This one you have 20.3.255.255. This one you have 20.4.255.255. So for the first usable, of course, is always the network ID, because this is the net ID. And these are the two addresses that we don't use. As in, now that these are /16, for you to get the number of hosts or the host bits, this is where we had 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8, and that is /16 here is the one that I'm writing in binary. Therefore, so for you to get the number of hosts, computers, you do 2 to power host bits, which is 16, and is the one that I'm saying is some 65,000 something computers in a LAN. That is, if you are to count this address all the way to the broadcast that we are writing, the ones in the middle there would be 65,000. Of course, you don't want to do the first usable, second, or all that all the way to the last. You would have to write 65,000. For the networks, these are the ones that we say 2 to power network bits. We added 8 bits. So when you say 65, okay, for the host 65,000, for the usable you have to minus 2, and that is this one here. You cannot use it in the broadcast. This other one here, you cannot use it in the broadcast. So those ones we have to minus. That's why we have to minus 2. For the networks is 2 to power 8, which is 256 networks. So we have met, these guys wanted 200 networks, so we have met and surpassed them. But anyway, to fill in these ranges, you just do 20.0.0.1, and then the last usable is 20.0.0. It's not .0.0 because the last usable is always the broadcast address you minus 1. So that would be 255. If I can write 255.254. I think you can be able to fill in all those others, and that's how we would tackle that problem using my 3 steps. But that's what we covered in part 2 of the previous, or that's what we covered in the previous video. So, but in an exam environment, you'll not be told something that is this straightforward, that given an IP address, given a block of IP addresses like this, subnet for 200 networks, you'll typically be something like this, where you're told, given the following IP address and subnet mask, determine the network address, that is the network ID, the valid host IP addresses, sort of like what you call reverse engineering, because somebody here subnetted. You see, this IP address belongs to a certain subnet, and this guy here had subnetted. So looking at this IP, can we be able to get where this IP, the subnet, where this IP belongs to, and all that? So the by the book way is you convert these things into binary. You look at them the way computers do. So once you convert them to binary, then you do an ANDing process. You do an ANDing process to, this is where you have this whole thing in binary and also the subnet mask in binary. And I think I showed you how we do ANDing for that. So But another shortcut that you can use is take 256 out of the blues and you minus 224, the last non or another best way would be, okay, so first of all you minus this, you'll have 232. Another better way that that might work for whichever class, because this will work best, this method here of 256 minus 224 will work best if you have a class C, yeah. But if you have, say, a class A and is the one that you are asked to harvest all this information, you can just convert this into binary, in which case you know that 255 is 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot. Now 224 is 1 2 3 or a slash 27. So then you have 1 2 3 4 5. So this is where I was saying that if we write our handy binary chart of 1 2 4 8 16 32 64 128, yeah. So 32 is matching to that there, and you can see that that's what we got. So I was saying, if say the zeros were coming to this octet using this method, you see this is now like step 2 of my subnetting back here, yeah, where you convert to binary, where we were saying that stuff. But I think you have seen how we do that. So our increment is 32. So in that case, you say that these guys at some point must have started with 192.168.1.0 /24. So then you start adding 32, our network ranges. Then you have 64. Then you have 96. Then you have if you add 32, that's 128. Yeah. So first of all, this computer was assigned a bad IP address. Yeah. This computer will not even allow you to assign it that IP address, because that IP address is the broadcast address. You see here we are supposed to determine the network ID. So the network ID here is 192.168.1.96. yeah, this one here, because this is where we are having the first usable IP address is 95.95. yeah, that is 192.168.1.95 all the way to .127. yeah, because 128 is the next network ID. So this is not a usable IP address, just like all these network IDs, they're not usable. So actually these are broadcasts, but to answer, these are the network address or the network ID is .96, and the first usable is 95, the last usable is 126. So you see here you are applying the skills of subnetting to, as in what I'm saying is, in the certification exam you'll not find something that is so direct like that. Another one would be where you are still applying your subnetting skills to see what's the deal. So you can see the user of computer A complains that he cannot access internet. As the network admin of this organization, you are asked to sort them out, write your answer to the solution. So what would you do? So when you look at this, and you can see how they can confuse you, this is where they have zoomed in and they give you the routing table of this router. So you look, you see these guys have a default route, because when you have a default when you have a routing table that doesn't have a default route, that would be number one culprit why guys there are not getting internet. But this thing is actually related to subnetting, because you can see that the default gateway here is 62, which is the right one that is assigned on this interface. But the thing here is, this is why I was saying that you can take 256 out of the blues, you minus 240. Yeah, so you'll find your increment is 16. So these guys at some point had to start with 172.16.68.0. Then you have .16.32. What is this? 48, if I'm not wrong. Then if you add 16 there, so you have .64, that's meant to be a 6. Then you have .80. So now when you look here, you can see this .65 is the first usable IP address, .65 all the way to .78. Those are the usable IP addresses in the .64 subnet. Yeah. Now for the .48, the first usable is .49 all the way to .62. So you see now here you have a computer that is assigned .65 is the first usable in this subnet. Yeah. But .62 is the last usable in this subnet. So this computer's IP address and its default gateway, they are on different subnets. So there is no way that computer can access the internet or can be able to communicate outside that network. Now the next style of subnetting that we have is subnetting with the requirement of hosts. Because in the previous videos we have been looking at subnetting with the requirement of networks. So this is where we would say an organization requires 200 networks and all that. So let's go back to the original scenario that we had in the first video of subnetting. Yeah. So these guys now, they are not concerned with networks, they are concerned with the number of hosts. So this would be a scenario where these guys are telling you that we have 3 branches, each branch will have like 30 employees, so they all need they need 30 computers. So we need to cater for those 30 employees. So we still use the same process of my 3 steps, where you say 2 to power what will give me 30. But when you're subnetting with the requirement of hosts, you need to remember that with hosts we always minus 2. Yeah, we always minus 2. But anyway, so here we need to write our chart. 1, 2, 4, 8, 16, 32, 64. I can write 128. So for 30 hosts, we see that, okay, this is 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4, 2 to power 5. So our x here is 5. Yeah, if you're to get 30, you need 5 host bits. Now you convert the subnet mask to binary and then add the number of bits that you determine. So this is the same step. So you do 1, 2, 3, 4, 5, 6, 7, 8, the slash 24. So 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. Now when we subnet with the requirement of hosts, whereas with the requirement of networks, we were counting the ones going that way. Now we count the zeros coming this way, as in we count 1 2 3 4 5. This 5 that we determined in step 1, we now count going back. So now we put these ones as 1, as ones here. So when we are subnetting with the requirement, that's the only difference when you are doing it with the requirement of networks and when you are doing it with the requirement of hosts. So with hosts, you are concerned with zeros, yeah, because it's the zeros in the subnet mask that give you the number of computers that you'll have in a subnet. So for you to have 30 computers, you must have at least 5 host bits, and that's what we have there. So the number of networks that you have created, because whether you are subnetting with the requirement of hosts or network, the goal still is to subnet. And to subnet, I've said that is always taking a /16, make it a /17. You have subnetted. In essence, is always about adding ones to the subnet mask. So just like what you have done here. So whether you're doing it to the requirement of hosts or networks, you still have to add 1. It's only that with the requirement of hosts, you count the number of zeros and reserve them. Yeah. So in this case, the number of networks that you create is 2 to power 3 because you have added 1, 2, 3 network bits. So those are 8 subnets, each capable of having 30 computers. Yeah. So our increment, of course, is 32. This is what I'm saying. If you do 1, 2, 4, 8, 16, you can see the last bit there is 32. And it's the one we are still getting by 2 to power host bits, which is 5 host bits, which is 32. But the usable IP addresses, you have to minus 2, so that you get 30 usable IP addresses. So, and our scheme now have gone to /27. So if you're to list the ranges, just do 216.21.5.0/27. So our increment is 32. And it always happens where you have your last network bit. So 32, 64, on and on like that, until you have 8 subnets. You have just listed 3.21.5 like that. All these are /27/27. So those are the subnets that so for the ranges, I think we have seen how we go about this by now. So the broadcast is 31 because it's the last. You know, if you have to draw my horrible table here, if I can draw straight. So you have 31 for .32 as the network ID. The last one is 63. This other one, you can figure it out. So the first usable is .1 and the last usable is .30. And that's why we are saying is 30 usable IP addresses. So you can do likewise for the other subnets. So that's how we subnet with the requirement of hosts. And so I think you can post the video and subnet this now using that logic, and see if you'll be able to. Looking at the time so that we don't have a too long video, I think I'll cover VLSM in part 4 of subnetting. So with that, I hope this has been informative to you, and I'd like to thank you for viewing.